Good afternoon and welcome to the Materials Testing and Properties webinar from TecQuipment. Today we're going to be talking about materials testing and properties, looking at it from a teaching perspective, a practical teaching perspective. My name's Dion Knowles and I'm joined today by three other individuals. We've got Kyle Hatchard, who's the UK sales manager for TecQuipment in the north of the UK. We've also got Dave Giddings, who you've seen many times, Digital Dave, in the background, sitting silently ready to jump in to add additional content, but Kyle will be running us through most of the material today. We're also really pleased to welcome a guest, Murat Islam. Murat is a design engineer and he's going to be talking about materials testing and how students can apply that to the real world, how he actually uses the principles and all of that foundation knowledge that he built during his time as a student in his everyday working today, working on couplings. So let's start off by introducing the gentlemen. Are you all there, gentlemen? Let's start off with Kyle. Let's say
yes.
Hi, Kyle.
Hi, Dion. Thank you. Yeah,
good to see you. There you are. You're in your home office, ready to go.
Absolutely.
Fantastic. Dave, next up, are you there? Maybe Dave's taking a phone call, feeding the dog. Maybe he's not. Let's skip to Murat. Murat, are you there on in your galaxy?
Yes, I'm here in my home. It's my own universe, I think, yes.
Yes, wonderful, fantastic. I want to start off by giving a few shout outs. We've got a couple of guys from UTC in Reading. It's great to see you joining us again today. I know David joined us last week. We've got Diana, who's also from University of Oxford. Great to see you, Diana. I know we've been having chats recently about remote lab videos. We've got Durgesh, who's here again. Do let us know where you are in the world. So please keep putting comments in that chat box. And Andy, we've got members of TecQuipment staff who are with us as well today. So good to see you there, Andy Ratcliffe, too. Andy is one of our members of our customer care team. Many people who will have wanted support with their products will have dealt with Andy and the likes of Dave as well. Let's get started now. First of all, many of you here today, and you've watched the previous webinars, know quite a bit about TecQuipment, but there are some people who don't know very much about us. So I'm going to do a really, really quick overview of who we are and what we do. Now, we're all about providing engineering teaching equipment, whether that's in civil engineering, mechanical engineering. As a company, we've got a worldwide presence in more than 100 countries, within more than 1,200 organizations, and it's very much a spread across the globe. In terms of size of an organization, we sell 9+ million Great British pounds around the world, and we've got 90 employees, but we achieve this by working with agents, sales partners around the world, companies and individuals who have local knowledge, local language expertise that work with universities and colleges to match their education teaching requirements to their learning outcomes that they need to achieve. As a company, if you want to know more about history, we were established 63 years ago. Then do have a look on our website. There are some very underarching principles about what we do. Yes, we make products for practical teaching. And what these are about is real life understandings that improve employability, make students ready for the world of engineering tomorrow, either today or the world that they're going into tomorrow. But we're more than just the products themselves. We see ourselves as very much holistically involved in the teaching process. We've got social communities that we host online. We do student competitions, all about engaging students. And it's engaging that takes me to principles of product design, because it's through fostering curiosity and sparking passion that we have as an objective for developing new products and enhancing our existing products. We also believe that we don't want them just to last a couple of years. We have a 5-year warranty as standard, but many products last long beyond that. We've got pieces of equipment that go back to the 1960s that are still in use. And that's because we design with standing the test of time. And at the same time, we're always looking at how can we make them, the equipment, the teaching apparatus, perform better, faster, while still achieving the learning outcomes. And our virtual data acquisition system is often a very important and powerful aspect of that, as well as really fostering passion and getting everybody involved. We're also about simplifying teaching, thinking about lab technicians and lecturers now. We're constantly working with universities and colleges and industry around the world to integrate functionality that match the changing syllabus requirements. And we also, to make it simpler, we provide supporting instructional and theoretical material. So with the manual, with the equipment, and often with some of the videos that we have online, you can pretty much up and ready to go without any further support. Some situations you'll need on-site training for some of the more involved products, and that's where the likes of Digital Dave comes into place as he travels around the world installing equipment and training individuals. But also our sales partners will be doing that for us as well around the world. So that's it from a company overview, very fast fly through there. Now I'm going to pull up Kyle. Kyle, it's your turn now to start talking about materials testing. But before you do that, hold fire. I'm just getting you ready. I'd like to do a few shout outs now. We've got Semi from Turkey. Semi, fantastic. Great to see you again. You're always there. Consistent presence, and of course Murat as one happy man to see a fellow Turkish person there joining us. We've got Serkan, we've got Matt Fellows as well. Matt is ready to judge you guys. Matt was a former TecQuipment employee. And we've also got other members of the TecQuipment team like Bruno. Great to see you, everybody. Do let us know where in the world you're from. Are you in your home office? Are you in the garden? I'm certainly not in the garden because it's pouring down with rain. So let's over to you, Kyle.
Brilliant. Okay, thanks for that introduction, Dion. Very good. Excellent overview of the company, I think. So obviously materials testing, it's fundamental really to mechanical principles and to the behavior of materials. And primarily within that, we cover destructive and non-destructive testing. And the exciting thing about materials testing is very much that you actually get to destroy elements and components really to destruction. So it's a very physical, hands-on part of your practical. And really trying to understand how those key materials behave and react to the forces that you're effectively applying to them. And obviously varying generally one component of that material at a time to then understand the properties of that particular material. And we'll come on to the importance of that as we move through the different pieces of equipment we've got that are able to demonstrate varying things like fatigue, shear stress, strain, understanding Young's modulus, ultimate tensile stress, that kind of thing, and elasticity. So we'll move through those as we work through the practical experiments that we're able to demonstrate for you. So yeah, Dion, if you want to move that.
Yeah, great. Before we do go on to introducing Murat, who's going to be talking about couplings, I'd like to do a shout out to Stuart Patterson from Newcastle University, who's also joined us on this webinar today. So this is the point where we invite Murat, who works in industry, to talk about how he applies the principles of material testing in real life, in real industry here. Murat, are you there?
Yes, I am here. Thank you very much for the introduction, Dion. As usual, you're amazing. Like you mentioned, I work in industry. It's a rotating machinery industry. So the parts we design actually spin very fast. They transmit a lot of torque. They are subjected to a lot of axial force as well as lateral or radial forces or centrifugal forces as well. So we need to really understand our materials very well. How do they behave under these conditions in the environments they're operating in? Like Kyle mentioned, we also have to do some destruction tests at times just to make sure the maximum capacity is very well defined. Because you will get some statistical results from all the experiments you run. And you just need to rely on the lowest value you get and maybe apply some safety factors on them to have a safe design in actual operation. Material point of view, we look into how stiff the materials are. Young's modulus is very critical for this. We need to know the Poisson's ratio. So what sort of volume change do you get when you actually extend a material or compress a material? We need to understand that. We need to understand the weight of the materials to reduce the weight, to reduce forces. Obviously, the machinery has a lot of components in them, and one of the critical one is a bearing. And if you have too much reaction force acting on your bearings, their lifetime will drastically reduce. So we want to make things flexible to reduce all the forces that generated by our couplings. But at the same time, you want to make it very strong, very, very tough. So we play with numbers, play with geometries, do simulation, do practical testing, and break things up, pull things apart, bring them back together and test them again over and over. There are many other properties we can be testing. You can look at material surface hardness. And if that hardness is too much for another component to be next to it, it will actually scratch it, it will wear it very fast. They may dig into each other literally, so you need to be careful on selecting that hard materials and using them together. And as you can see here, at the left, right-hand side bottom, the actual static torque test rig that we have. This rig actually applies pure torque on the coupling. There is no axial force, there is no lateral force. All we are doing is moving two lever arms to create pure torque in the system. And for that, you then calculate, actually measure what is the stress level on the spacer tubes you are using maybe. And if my coupling has some membrane shapes built in them, which I can't go into much detail here really, how are they impacted by this? What sort of deflections do I get when I put certain torque values through my system? So we have to run various performance tests, and that requires obviously understanding the materials. Is there anything specific you want to talk about, Dion?
No, that's fantastic. A really brilliant overview there. Thank you very, very much. Is there anything you want to add?
Well, there isn't, unless I have a specific area to talk about,
okay.
I can go on about many things.
Okay, well, I should remind everybody that we are live right now, and this is your opportunity to use the chat box, ask questions. Murat's not going to be with us for much longer. Murat has a day job to do, and that's not with TecQuipment. That's actually working on couplings. So Murat does need to dive back to his day job shortly, because we already took his precious time yesterday during our Wednesday Q&A live sessions. If you want to know more about Murat and his education and life story, then do go back and watch the Wednesday Q&A live session. Murat's got a really interesting story to tell, how he moved from Turkey, from his hazelnut farm, and moved to Manchester, and how he's a very accomplished engineer now and does lots of outreach programs. So I think that's it, Murat. We've now had no further questions from the audience today. People can, if they're watching this on demand, put questions in the comment box, and we'll chase Murat down and get some answers for those as well after that.
Thank you very much, Dion.
Thank you very much, Murat, and we look forward to speaking to you again another time. You take care too. Thank you. So now, this is the point where we hand back to Kyle. Kyle's going to tell us more about, in detail, materials testing and practical teaching, the different elements. Are you there, Kyle? I think you want to talk about Young's modulus as a starter.
Yeah, so I think it's key really to everything that we're discussing around materials, and as Murat sort of touched on, they use that a lot in industry to understand the behavior and the reaction of those particular materials that they're using in couplings. So we've got a curve there in front of us, and you can see a linear rise in that curve, and that's effectively a Young's modulus curve that's comparing stress against strain. And typically you would create this curve using our SM1002 tensile tester, or even the universal tester, and the MF40 Mark II. All those three pieces of equipment enable you to effectively place a component or a test piece into a tensile tester and extend it to the point of fracture, which you can see the point at which it's marked X in red. So as you see the elastic limit, so that's the linear rise in that curve from 0 to where it marks out the yield strength. And that's effectively identifying Hooke's law again. So that brings you into the SM110, which is basically understanding how springs effectively work, where a material in that region is able to return back to its original shape or form. And anything then beyond that, so you're reaching where it says the yield strength, you then start to see it's reaching its plastic deformation. And that basically means that it's not going to return back to its original size and shape, and therefore you're going to ultimately reach its ultimate strength, and eventually it will fail. Before it fails, the actual material starts to neck. It looks like it's becoming weaker because you see that the strain starts to drop, the stress starts to drop on the material, and then eventually you see the fracture, which causes the failure. So that's obviously really important from a material's properties perspective to understand how the material fails, how durable it is in operation, and different parameters that you can obviously adjust to ensure that that material is safe. And a lot of material testing is all about understanding whether that material is safe for that particular application. So yeah,
I was going to talk about a slinky, but it's not really very serious when you're talking about safety here. Later on, you can go on to talk about aeroplanes.
Talk about slinkies. Slinkies are pretty serious. It depends how much you love slinkies. I mean, yeah,
I love a slinky.
Yeah, everybody loves a slinky. So yeah, effectively, it's a good example though. You know, if you take a slinky too far beyond its elastic limit, it won't then return back to its original shape to allow it to obviously spring into action down the stairs. And it's the same idea with a spring, really. If you pull it too far, then the material deforms and it doesn't then return back to its original shape. It's the same with,
and then it gets mangled up and it's an absolute nightmare to unravel.
Yeah. And that's another engineering problem.
Yes.
So yeah, so that's where we are with obviously stiffness and bending and torsion. So we've got the TE16, which is a relatively simple, straightforward benchtop piece of equipment to demonstrate that and those fundamentals, which is more of an introduction, to be honest with you, into those elements, but great for obviously separating out classrooms and things as well in regards to practical teaching. So you've got a bit of a video there, Dion, I think you were.
Yes, we're not going to play that today. I'll put it in the comment box. For those who like to know a little bit about history, then we have a video on Young's modulus, Thomas Young, in fact, and Young's modulus, because he was the inventor of Young's modulus. So do check that out if you are interested. It's very brief. Now, Kyle, tensile and universal testing machines. These are quite exciting because you get to break stuff. I mean, I know it's not all about breaking stuff, but still.
No, it's got to be. Yeah, absolutely. Not all of it is, but definitely destructive testing is a fundamental part of materials. So understanding how those materials behave when you're forming some form of test and how they react is fundamental and crucial. And these three pieces of equipment allow you to do that at various different stages, to be honest with you. So if we start with the MF40 Mark II, so that allows you to effectively apply a load, which you can see on the left-hand side there. You load that with a specimen, and then you hand operate via a hydraulic pump the force and the tensile tension, which then feeds back into the VDAS software and allows you to effectively plot the graph, the Young's modulus graph. Very compact, unique system, and very versatile. The benchtop tensile testing machine, the SM1002, that's a great piece of equipment to obviously allow academics to deliver and teach students on the principle of Young's modulus again. However, with this particular piece of equipment, I prefer this and sing the praises of this piece of kit because it gives students that engineering empathy, that engagement with the material itself. So as you work the handle, the big black handle that you can see there, that then draws the specimen backwards through via the screw thread and you're actually able to feel the piece of material tensing as you apply the load. That then feeds back through a strain gauge, which again allows you to then take the data and information into a software format, which then allows you to take the data into a graph form and obviously plot the curve for varying different pieces of specimens and different carbon percentages, which obviously has an impact on the hardness and the reaction of the material.
I don't think you can stress enough how engaging this particular piece of equipment is, because it is full on hard work, and it's quite dramatic as well. I get a little bit nervous when we get to the breaking point because it's quite a big jud and bang. In fact, the demonstration video we did last year, I do a pathetic squeal, and it's just, you know, it's pathetic, frankly, but you can't help it. And I think it's quite a natural response because it is so engaging. Many people like to use that when they have students come around and visit the university because it is so hands-on. Actually sensory, I suppose.
No, absolutely.
Rebecca has asked a question. She said, do you have any videos of the test being conducted that could be used for remote style lab sessions? Rebecca, we don't have full videos that cover all of the experiments, but we do have product demonstration videos, for example, of the universal testing machine, where you can see it working, you can see what's happening, and you can see lots of other different experiments that we can put in there. We have cupping, and we have spring rate, and we have a shear test experiment as well that will go inside of that universal testing machine.
Yeah, no, absolutely. So that brings us nicely really onto the universal testing machine on the right hand side of those images, and that again it builds on the versatility of the.
Sorry, that's the one I was talking about.
Yeah. And there's various options. So with the middle machine, you can obviously add as well the hardness test of the Brunel indenter, and that's great because obviously you've got varying different academic and teaching principles that you can deliver with that. So you're opening up your options with that one piece of kit. Now, again, that extends even further with the universal testing machine, which is on the right-hand side, because not only does it then take it to a higher force rating in regards to 100 kilonewtons, it also then allows you to demonstrate shear stress analysis, which really is a very important part of material testing as well. And trying to understand how materials effectively work in shear. Now, shear is, if you think about, if you have your hair cut, you're not cutting the hair, you're shearing it. The same with a piece of paper. If you have a pair of scissors, you're shearing the paper, you're not cutting it. And this is something that took me right back to when I was studying, and I remember my academic was teaching me, and I found that really bizarre to understand that concept. But basically, shearing is where two materials are moving over each other, and it's the force applied to then effectively ultimately break those two that material apart away from each other, and it's shearing, that's the effect that it causes. So that's one demonstration that you can also add to that universal tensile tester, along with compression testing, and some academics like to use that for testing concrete blocks, for example, to destruction. So civil engineering departments particularly like that piece of equipment. So yeah, that's a quick summary really in regards to the tensile testing and Young's modulus, and just, you know, a variety of detail that we go into and being able to deliver that.
Okay, so now you've got impact testing and creep testing.
Yeah, so creep testing, this is all about elongation of the material over a specified or particular time period. This is the SM1006, quite a compact unit, benchtop. It allows you to load some predefined specimens in there, and then obviously apply a weight or a load, and the specimen will elongate over a period of time. So you're moving the material from the elastic property, from the elastic limit. So if you go back to that original curve that we're thinking about in the linear section, and then eventually as the material elongates, it reaches its yield point, and then extends over through the three different points within the creep test. Just really similar as you were to Young's modulus. But it's all about a constant load that's being applied. And these tests do take quite a while if you've got the strongest types of material. So nylon, for example, is very easy to visualize because it stretches quite quickly with a low mass. However, but obviously that depends on the size of the specimen and the thickness and all those parameters. So you've got to keep those consistent. But if you take a real life example of that, a great one would be perhaps a buoy, for example. A recent discussion I've had with an organisation is about looking at how they obviously manufacture buoys in a marine context. So if you're in a harbour and you've got a boat up against a harbour wall and it's constantly applying a force to that buoy, which is creating a buffer between the wall and the boat, that eventually that buoy will elongate, and it's the phenomenon of creep that really creates that elongation, that point at which it's gone past its elasticity to be able to return back to its original shape, but over an extended period of time. So yeah, hopefully that gives a bit of an indication as to what creep is really.
Fantastic, Kyle. And we've got an ice pack there and shown on the picture. Can you explain more about how we use that with that piece of apparatus?
Yeah, so the idea is with the ice pack, as you alter the temperature and the atmospheric temperature, as that changes, the material behavior changes. So you place that ice pack in the freezer and you can see that cylindrical compartment. Once that's frozen, you place the ice pack in there, and where you're hovering the mouse around there at the moment, Dion, you can see 2 notches, and you apply the specimen in the middle of that, and therefore the idea is to cool that chamber effectively so that you change the behavior, the properties of that material slightly, and you will see the reaction of the material change dependent on the environment that it's in. So that's effectively demonstrating to students that obviously creep changes and materials behave differently depending on the environment that they're in from a temperature point of view.
So if your boy's in the Arctic versus the...
Yeah, between the Sahara and the Arctic, you're going to get reactions. Yeah. So then we move on to the energy absorbed at fracture. So the energy absorbed at fracture, this is all about understanding the point at which crack propagation occurs and the energy that it takes. So it's not about crack initiation. So what I mean by that is that you have a test piece of material, you slot the test piece of material into in between the 2 circles at the bottom of that particular apparatus. There's a swinging arm that then you rotate 90 degrees to the right with the test piece in. You've created a notch, and the notch is to create a crack initiation, because if you didn't create that notch, you would then basically be investigating the crack initiation, not the crack propagation. And it's crack propagation that you are interested in, the energy that it takes effectively on impact of that particular material, and to actually fracture that material. Again, so it's a destructive test, demonstrating to students the importance of what energy is used in that material, what energy is taken to fracture that particular sample. And obviously different materials, so copper, brass, steel, aluminium, all behave differently because of the properties of that particular material.
Thank you, Kyle. I've got a question from Martin Thomas. I think he was about to ask a question, but I think he's figured out how it works now with the ice pack. So You've already answered that. I've got another question actually from another Martin from Make UK. He says the TE15 is a desktop version of a Charpy, Izod or Hounsfield tensiometer. Which one is it? Do you know?
It's a Charpy. There's a Charpy tester.
Right. Okay.
Yeah.
Great.
I mean, they're very similar tests, to be honest with you. But yeah, it's closer to the Charpy test. And yeah.
Okay, so keep those questions coming in. Keep letting us know where around the world you're from. It really is great to see the worldwide distribution of attendees with us. Right, Kyle. So now back to you. If I can get Prezi to play ball. We're talking hardness testing now.
Yeah, so obviously hardness testing from a materials perspective is pretty important. If you think about, the rail industry, a rail track, the hardness of a rail needs the impact that that particular material is taking daily, you need to have the peace of mind that that material is, effective in its operation. So understanding the hardness of the material, these 3 pieces of equipment all allow you to do that, and they all follow very simple, very similar principles in the sense that you use a diamond indenter. Obviously, diamond's the hardest material available to man, and you indent the specimen, and then obviously measure the cross-sectional area and relate it back to the various charts, so whether that's a Rockwell, Vickers, and the universal, effectively, SM1017 allows you to cover all 3 effectively. Brunel, Hardness Testing, Vickers and Rockwell.
Great. Good. Freestanding structures experiments. We recently launched new demonstration videos of these, along with launching the composite beam sets.
Yeah, so the Euler bucket of struts, the SM1005, we demonstrated the vertical version of this from the structures range back in, when was it we did that live? Was it theory of machine, which was it, structural civil engineering?
I think it was in February when we did theory of machines, was it?
Right.
When we did that?
Yeah.
Or was it civil engineering live?
Civil engineering, so it was even further
that would
back
have been last
then.
year.
Yeah, so only feels like 5 minutes ago. So when we spoke about the Euler bucket of struts, effectively you've got various different fixing points on that piece of equipment. So we have a structures range that effectively covers the same principles. However, this is a benchtop version and allows you effectively to understand the failure rate points, really, of point of buckling. And that's important in regards to applications such as a steering rod that goes into your steering wheel in a car. You need to know the point at which that's going to fail, because if you have an impact, front impact of the car, you don't want that to obviously pierce the driver and et cetera, et cetera. You'd like to make sure that that particular piece of material is going to fail, and you would use Euler buckling to calculate that failure point. And this piece of equipment allows you to explore the various different fixing points to explore Euler buckling theory, and then relate that back to how varying different materials obviously as well react. And I think within that sample set, there's specimens such as wood, steel, brass and aluminium.
Yeah, there are. I recall when I did the video a few months ago.
Yeah. So no, it really is a very, very useful piece of equipment from that perspective, and it's great for students as well, because some students find the theory side of Euler buckling a bit heavy, and trying to get their hands on the practical equipment really evolves that experience, really, and gets their head around, why is it fixed and pinned fixed and that kind of thing. So moving on to the SM1004, again, I really like this piece of equipment because it's relatively straightforward. You're introducing bending moments, and obviously there you're able to develop and understand how sort of torque is calculated, but also it applies quite nicely to civil engineering and simply supported beams, where you're measuring the deflection of a particular piece of material, and the forces, as the force is applied, how that material reacts depending on where it's supported. In addition to that, you've also got the cantilever apparatus, so you can understand perhaps how a balcony may react if you're applying, or if you're loading the balcony in a particular situation and you've got an overhang. You can understand how that might react with a set force that's applied.
And that's in the structures range, isn't it?
Yeah, that's right.
Yeah.
With that as well, it's worth mentioning that there are also a series of composite materials that are available to test on that too.
So here we are. We can take you to have a look at those composites quickly, if we can skip past that bit. Here we go. I'll show you the composites. We've got 3 different sets of composites actually, for different levels of understanding, whether it's a honeycomb or a foam core, different actual constructions at different degrees, so that you can really study various different depths of composites, as you can see there in those images. If you want to know more, you can have a look at this video separately that is listed on YouTube. strain and stress analysis. Are you feeling the strain today, Kyle?
I'm all right.
Any
Actually.
stress?
Yeah, no, it's yeah, not too bad. Yeah.
Good, good, good. And before we go on to strain and stress, as you're so relaxed, we're going to throw a question at you just to see if we can stress you out. The beam apparatus, can it be connected to the simulation structures software?
The SM1004, yes, you can. So you can attach the gauges effectively into the beam software.
Does that into VDAS or the
VDAS,
yeah, so it's
yeah.
not the
It's
structure
not the structured
software, which is separate.
itself, it's separate. So the structures range is separate with the structured software. The bending of beam apparatus is effectively around the material testing side. So you can still attach the VDAS and then obviously take the data digitally. However, obviously the structured software side is separate.
Okay, brilliant. Danny, I hope that answered your question thoroughly. If you've got any more questions, then do send them our way. See if we can actually get Kyle to break out into a sweat with stress. Go on, yeah, tell us about your strain and stress.
Yeah, so strain and stress, or stress and strain, really. That's the way around it should be.
Oh, is it? Okay.
No, there's no criticism of you, Dion, don't worry.
I'm feeling the stress now. Sorry, carry on.
Just in relation to, you know, thinking back again to the Young's modulus curve and how you plot the graph, really. But it really, stress and strain, obviously, stress analysis is important, understanding how that material reacts, and obviously strain from a strain gauge point of view, how that material behaves. So we've got the strain gauge trainer, the SM1009 on the bottom right hand side. That really is a great introduction into how strain gauging works, and the principles around that. Now, that obviously then feeds back into our VDAS system, but you can apply varying forces, varying loads, or even a torsional effect to the specimen, as you can see to that display board, and that will feed back as to how the strain gauge is effectively feeding that information back to the software, and it gives students really a fundamental as to then, right, we're using all these varying different pieces of equipment. So we move back into then the thin cylinder, which again uses strain gauges to understand how how that surface behaves. So you can see a series, maybe a little orange tab on the top of that image if you can see this video close enough. And that's effectively where the strain gauges are placed. And with the thin cylinder, you apply an internal pressure, which then obviously changes the behavior and reaction to the surface of the cylinder. Now, a really good example of that would be an aircraft fuselage, and that it would reach a cycle rate effectively once it's reached the atmosphere that it goes to. So if you take off and you reach cruising altitude, say 35,000 feet or something of the like, and the cabin is pressured usually to normal atmospheric pressure that we're used to, but obviously the air and the atmosphere and pressure up there is a lot lower. So there's a force on that cylinder effectively, and that canister is effectively then being worked. Every time it's going up to that pressure, it's a cycle, and that's effectively got a cycle rate every time it's going through that series of data points. So that's a little bit on thin cylinders. Thick cylinders, we then move into a cylinder that would perhaps be used as an example in the nuclear industry, maybe, for containment of particularly nasty substances. And generally it's where the wall thickness is 7% or more greater than the internal diameter of the cylinder. And it basically allows you to understand and operate when you apply the load to the material internally, with varying different pressures, how that affects the cylinder and how the behavior of that cylinder reacts.
Thanks, Kyle. Great. Okay. We've got the strain gauge trainer kit there as well, haven't we? Just a little simple.
Yeah, little nice top-up kit. So that obviously complements the SM1009 as well quite nicely.
All right, next one is torsion and fatigue. Simon has been waiting for fatigue. There you go, Simon. Not Martin, but Simon.
Simon, right. Hi, Simon. Okay. So fatigue, I particularly like this fatigue testing. And no, we're not talking about working from home in these current site situations. It's about rotating fatigue. So, this particular piece of equipment is fantastic for that. And again, we talked about cycle rates within a fuselage in an aircraft. It's about continually taking a cycle rate to a specimen. So you can see in that picture there very faintly that you've got a specimen applied to the front of a motor, and you cycle that motor over a period and apply a load with a series of weights on the bottom arm there. That then allows the material to be offset ever so slightly. And eventually what will happen is that material will reach the point of failure through fatigue testing. And then again, this is something that Murat would be very, very familiar with in regards to lifetime testing of a product. How long will a product last until it reaches the point of failure effectively? So understanding how materials react in a coupling, for example, are fundamental.
Good, so torsion now.
Yeah, so moving on to torsion testing. This again is quite a straightforward piece of equipment, and again you can take specimens to destruction as well, nice and safely for the students, and it allows you to calculate the second moment of area, polar moment of inertia, and really get an idea of the effects of torsion. And whether you want to work within that elastic region and you see the material return back to its original shape, or whether you want to take it to destruction as well. And again, with the VDAS software, as you can see on that demonstration, you can plot a nice curve and create your data as well to feed back into your applied lecture. Great.
There we go. And now, in fact, we're going to talk about case studies. Now, I've not got all of these on the screen. There are a few case studies that I thought I'd mention. One of those is Birmingham City University. Birmingham City University, they've got an extensive lab there. They've got all kinds of pieces of kit. I know they've got the beam apparatus, along with various other fluid mechanics, thermodynamics, engineering science kits. We have got a video case study on YouTube and on our website. So I would encourage you, if you're interested in seeing how a lab setup really works in the real world, have a look at the Birmingham City University case study. There is also a written case study on a website about Northwestern University in the United States of America. In fact, they use the universal testing machine and various other pieces of material testing apparatus. So have a look at that one too. It's on the case study section of the website that you can navigate to from the home page along the top. Bedford College. They have they're teaching civil engineering and construction management. They've got extensive amounts of materials testing equipment, whether it's thin and thick cylinders in there. I think they might have a fatigue testing machine in there as well. They've got equipment that dates back years and years and years, and they're currently expanding their facility there. And they use that for teaching that civil engineering and construction management. Have a look at the case study that we published recently. There's Teddy Kai Nyarko talking about what they're trying to achieve at Bedford College and what apparatus they're using. Then Northumbria University. Kyle, this is your territory. Have you been along to the labs at Northumbria?
Yes, lots of times. Yeah, I have to say that. No, I'm only joking.
Good. Yeah, nod.
No, they've got a fantastic array of equipment up there, and they're very lucky really to have such in-depth equipment for sure.
Including obviously the materials testing that we're talking about today. They've got fluid, aero. Again, if you want to know more about this, have a look at the case studies part of the TecQuipment website. We have them all on there. We have a mixture of video case studies and written case studies. So that's it from case studies for the moment. And that's pretty much it from materials testing. But keep your questions coming because Kyle's not going anywhere. And I'm going to talk a little bit now about remote learning support. Then Kyle's going to come back and talk about ranges. So if you're unfamiliar with everything else that TecQuipment offers, we're going to be flying through fluid mechanics, engineering, science, all the different ranges. I'll come back to talk about activities that we do in terms of being a holistic partner in teaching, and then we can go through any more questions that we haven't answered through the course of the webinar today. So Kyle, you can sit back and relax while I talk about remote learning support. Now, Rebecca's already asked us today whether we've got any videos that demonstrate the pieces of equipment being used. Mostly we have videos that are demonstration videos, we have customer care videos. What we have got is a video that you might find useful, is we have a video that's all about how to create your own lab experiment videos. Now this is a very simplistic view if you want to create it from your phone, for example. Now some universities are investing heavily on video equipment. I think just a word of warning there, you need to be really, really careful because you can go out and spend thousands of pounds, but unless you can find equipment that you can use where functionality is not too complicated, you're going to find it really hard to get on with it. We use a Panasonic GH4. That is a 4K camera. This is what you can see on our latest product demonstration videos. And that is a really reasonably priced camera. You can buy the lenses separately. You need to buy, obviously, a tripod to go with it. You need to think carefully about your lighting and sound in the background, shutting doors, making sure there's no big machinery noise. Or sometimes I'm filming case studies and there's heating and ventilation systems burring away in the background. That can be an absolute nightmare. So you need to find ways of shutting those off. Now, and maybe you need to think about how can you do interactive videos. Maybe you want to think about live streaming, like we're live streaming here today. You may want to use Zoom technology or something like that to live stream your labs themselves and have your students join in, participate. With that, you can also pre-record segments. So you can pre-record little bits of close-up video that you can add to your main Zoom live session. We'll be coming back to you next week in our live Q&A session on the Wednesday to talk more about that, but you may want to check out this video in the meantime. Other things that we're doing in order to help support you around the world with remote learning is the live Q&A sessions. These are every Wednesday. They take place at 1 o'clock British Standard Time. That's the same time as we started here on YouTube, but that one's on Instagram. And then you can join again. We do it on YouTube at 2 o'clock British Standard Time. We feature a guest. We have Digital Dave on there answering your technical questions. And next week I'll be talking about these lab creation videos as well. So do join us for those. It's very much of an open session where you can ask your questions. Other things, we've got a resource area on the TecQuipment website. It's tecquipment.com/remote-learning-support. On there, you can find links to student experiment videos. We're releasing pretty much a new student experiment video every week. So if you're not already subscribed to the TecQuipment YouTube channel, I would recommend you do, and then you'll get notifications of when those new videos come out. We've got a resource, a PDF of other engineering videos. This is the engineering videos guide there. These are not just TecQuipment videos. These are videos from the likes of practical engineering that really show, for example, might explain what a culvert is, or might explain different fluid mechanics, civil engineering phenomenon that can supplement your online learning resources that will help improve the engagement with your students. Next up is, I mentioned the communities. We've got communities on LinkedIn and Facebook. These are the practical teaching and engineering education communities. These are for lecturers and lab technicians. They aren't for students, so it's a free area where the actual teaching environment audience can discuss topics among themselves. There is an open area which does include students as well on the YouTube channel. So when you're done here today, you might want to have a look at the communities tab, have a look in there, feel free to engage, start a conversation with other people that are on the community. So that's pretty much it. But we are also working individual basis with universities to help support them with their individual needs. So do reach out to us. Let's have discussions about how we can move forward. It's a changing landscape every single day. It's different, and we are trying to do our best to see what's going to be happening in the future, reflect it in what we offer and how we best support you. So keep in touch, keep communicating. Kyle, you've had a cup of tea or a cup of coffee. Are you ready for Rangers Overview?
Round 2, absolutely.
Round 2, let's go. Oh, but before, I must ask Sambit's question. Sambit's great to see you again. Sambit asks, do you design these equipments in AutoCAD or any high-end software? We do. We use SolidWorks, actually. We do a lot of our design in there. We use specialist electronics design software as well. I think we use Cadence's electronics design software. Yes, so it is a very high engineered process that we follow at TecQuipment. Back to you, Kyle.
Awesome. Okay, where do I start? So structures seems quite the natural one to go for straight away. So if we start there in the top left-hand corner, Dion, is that all right with you?
Yes, let's go to structures. There you go.
Yeah, smashing. So obviously structures really dovetails quite nicely into materials and obviously material testing. We've got a variety of different structures, equipment, which cover obviously the fundamental principles in regards to things like bending moments in a beam, arches, and roof trusses as well. That's another one that's very popular. There's 19 different experiments that are available within that frame, that mounted frame, the aluminium frame that you can see. So that's effectively the base unit, and then you add the different pieces of equipment to that frame. And again, from a storage perspective, that makes it ideal. You've not got multiple frames constantly set up. You can apply different experiments to the same subframe and run that as well via the structures software. So the structures software is really, really powerful in regards to engaging with students, giving them that pre-lecture or pre-practical experience and engagement with the equipment itself. And that's really important because that saves time and it makes the practical session a lot more effective and efficient because the students are already familiar with the concept of the practical application. So they can run through the process and steps beforehand, which are really useful and a great benefit for most universities now and colleges. And to be honest with you, with blended learning coming online and being so relevant lately, again, it's another excellent addition to obviously delivering principles online. It's a very straightforward piece of software. It's very easy to use and very intuitive, and allows you to effectively plot the data, hanging a series of weights on a beam, and feeds back, and you're able to then analyze different reaction forces effectively, dependent on the amount of load you apply and where at what point, and obviously understand compression and tension as well, which again from a materials perspective are very important to understand. So that's
brilliant. We've got some exciting news coming up soon. Can't tell everybody what it is, but there is news on structures coming in a few months. So do watch this space.
Absolutely. So yeah,
What do you want to go to next?
So what was next on that slide? If we would work our way down.
Do you want to go to we go to engineering science and then it kind of automates itself? Can we do that?
Yeah.
Up to the other side. There we go.
Oh, we can go.
This is my new favorite range. Every week I do a different video from home.
That's great. No, these are brilliant kits. So the engineering science range, effectively, you've got a trolley load, as you can see in the image, and you've got these obviously backboards, effectively, that you can apply different principles, different tests to, or run experiments effectively with the students. And you can see the ones that are set up there as a basic tensile tester. So it introduces you into a very simple form of tensile testing. There's ultimately 66 different experiments that are available within the 18 kits that you can see within that trolley.
66. I was wondering what that number was the other day, actually.
Yeah.
What is the number? I know we've got 18 different kits, and I've been going through and doing these different experiments, but that's the golden number.
It is, and I think, you know, try not to just sweep over that too quickly. I think it's important to understand the versatility of these really straightforward, simple pieces of equipment. These are your sort of baseline foundation sort of building blocks and introduction into the rest of our range, really, and it allows students to become equal on understanding in regards to their. So we know if you've got a new intake for your undergraduate year 1, for example, and you're coming from varying different levels or different backgrounds, you may all have, may have a selection of students that aren't all at the same level of understanding. And this is a brilliant piece of equipment that allows you to bring everybody up to that standard relatively quickly. And again, as well, it allows you to drop back into, so if you've got a lab that you were hoping to run and for whatever reason weren't able to do so, these pieces of equipment give you that versatility to be able to drop into something that would be relevant, again, to the students.
What I like about this is all of the kits, they can be used at different levels as well. So you're saying very basic level, but they can be really, really basic. So you can still get a handle on this by, for example, I've been doing these experiments at home with my kids. I know that's not the target audience, but they can still begin to get a basic grasp. So if you're thinking GCSE engineering or something like that, you don't have to do all the maths and do all the readings to be able to start getting any appreciation of the concepts, but it can, and the manuals have got everything in there step by step through it. I mean, I'm no engineer, and I've been able to sit and take myself through all of these without anybody's help, even chart all the results and things like that.
No, absolutely. And from that perspective, Dion, they're really versatile and very powerful pieces of equipment. And a great resource that really every university or establishment should have. And again, you touched on, schools and colleges. It's ideal as well for that platform.
Right, now we can talk fluid.
Yeah, let's move into fluid mechanics. So fluid mechanics range. So we've got quite an exciting array of equipment really within the flumes side. And that could be a piece of equipment that's perhaps 20 meters long and 600 millimeters wide. So we're talking about the FC 600 there, right down to the FC 80 and the smaller 5 meter flumes that are available. Now, fluid mechanics, to be honest with you, it's quite a large range. It includes the hydraulic benches. The image that you can see in front of us is actually a flume. That's a 10 meter flume, similar to one that Derby University have as an installation. And it's particularly useful for research and development, understanding how fluids operate or behave in flow channels. This can be, particularly interesting if you're wanting to affect the bed, for example, of the surface bed. You can have a roughened bed and see how the bed itself affects the behavior of the fluid on top of it. So that's just one example, really. And again, as I've touched on before, the H1F is a great piece of equipment, which is a bench top, a bench, hydraulics bench that allows you to adapt 19 different experiments in addition to that particular hydraulics lab. So yeah, engines. We've got a series of different petrol and diesel engines, regenerative test sets, exhaust calorimeters, engine crank analyzers. So you can really dive deep into the understanding of petrol engines. control
we do
engineering.
diesel engines as well, so it's not just petrol.
Yeah,
and then we've got all the gas,
right.
the
Yeah.
big gas turbines and with kerosene and
Yeah, absolutely. So control engineering, we've got a selection of equipment. Obviously, it allows you to understand feedback and control, so PID, and how that affects behavior. So one particular popular piece of equipment is the ball and beam. So you've got a ball on a beam, and you've got to then balance the ball on the beam to stabilize the system effectively. And that's pretty much where control engineering comes into its own. It's about stabilizing the system. So process control. So this is, again, so you're covering pressure, level, temperature, and there's one more, and it's escaped me. Must be the nerves of being live, Dion.
I'm sorry, I don't know. Dave, are you in the background? Can you step in?
Pressure, level, temperature, and yeah.
No, maybe it's not.
Level.
Cheers. Pressure, temperature, level. Pressure, temperature, level. Yeah. Okay. Is that right? Okay. So yeah, those four elements, obviously, you can understand from a process control perspective.
And flow. Don't forget
flow. That's it. That's the missing one. Flow. That's right. There you go. Nice one. Cheers.
Yeah, my contribution today.
Yeah, that's it. See, that was it. I was just trying to build you in, really. Electrical power systems. So again, this is part of our industrial range. If you go to our website and click TQ Industrial, you'll see a huge selection of electrical power systems. And this really fundamentally demonstrates how the grid operates. So you can be talking from low voltage right up to from MV, medium voltage, and high voltage transmission lines, and gives students the opportunity to understand the various different fundamentals within that operation, really. And I would urge you to go and have a look at that if that's from your background or some interest. There's some really, really good practical equipment for that. So environmental control. So you've got
you can't say too much about this, Kyle. And the reason why you can't say this is because we're doing this one next week. So you can just tease, right? Right.
So from that, then, we've got to definitely open up the fact that the HVAC and R, so heating and ventilation and control equipment and refrigeration is really interesting. So you've got to tune in next week to see what the capability is of that particular piece of equipment alone. That's more worthwhile than anything really in regards to tuning in next week. So it's quite exciting. But that particular environmental control side covers a range of different aspects of equipment. So moving into thermodynamics, the TD360 is a particularly popular piece of equipment. That's not that image that you can see there, but the TD360 allows you to really deliver and demonstrate thermodynamics very effectively to students. And heat and work transfer effectively. The image that you see there is the Marseille boiler, and yeah, it allows you to obviously understand different principles within fluids, so and heat transfer.
If you want to learn more about the thermodynamics, we did a webinar on that last week, so do go and check that one out. Now we've done structures now. A bit more on VDAS.
Yeah, so VDAS, there's two formats of VDAS. We've got the benchtop version, which is in the top right-hand corner. And VDAS is Versatile Data Acquisition System. And the left-hand side, you've got the VDAS F, which is a frame-mounted version that effectively allows you to obviously take data from the various different strain gauges and systems and then plot that back into the software program.
That diagram showing the creep machine as well, so it's perfect, nice, very suitable for this one actually. It's also worth mentioning that while we do have the frame mounted and the benchtop mounted hardware interfaces, more and more we're integrating the VDAS on board into products, and you can see that if you're going through the products on the TecQuipment website or in the catalogue, they have the V on the end of them to denote that it has got VDAS on board, so you don't have to purchase the hardware separately. And then the software that's available to freely download from the website. The beauty of that is that as many people, students, academics alike, can download the software freely and put it on their own personal machines or on the university and college desktops.
And one thing to mention as well, you can integrate it with LabVIEW as well, so it opens up its versatility even further, really.
Brilliant. Okay. And another range which is coming up next week is solar. So I think you can have a look at the pictures. Kyle, we'll skip past that. Join us next week.
Yeah, okay, all right, yeah.
Unless you want to say something, go on.
No, it's great from an environmental perspective. Obviously, this is a very important topic that we should all be, very familiar with, really. And the solar cell on the top right-hand side is also very useful for understanding how batteries operate. So it's mentioned solar there as well, but obviously understanding how batteries charge and things is also, critical. So yeah, these are particularly popular pieces of equipment.
Great point. Dave's favourite topic. You're going to have to keep him on mute before he jumps in. Aerodynamics.
I heard that.
Hey, hush down. You can't. This is Kyle's show.
Yeah, you didn't even say the word aero, and he was on.
Who's doing this one? You go for it, Kyle.
Yeah, we've got a great range of aerodynamics products. I mean, from the benchtop wind tunnel, and the AF10 fundamental units really that demonstrate that how aerofoils operate effectively, and also demonstrate Bernoulli's theorem and flow around a bend, that kind of thing, all the way through our AF 13, 14, 15, 1600 range, which are our subsonic wind tunnels, and also the AF 1600 it goes up to effectively a 600 by 600 cross section working area, and really popular piece of equipment, very engaging from an academic's perspective and also as students.
There is a webinar, isn't we? We did the webinar about a month ago on this one. We also have Aerodynamics Live. You were featured in that as well, where we demonstrated the equipment live in the factory last year. So I'd encourage anybody who's watching interested in aerodynamics, have a look at the webinar and have a look at the live event that we did last year. You can really get a full appreciation for the scale and magnitude of some of these pieces of equipment.
Yeah, and I think in addition, obviously to that, we've got our supersonic ranges, which again, for students to have the ability to run a practical on how supersonic, flow operates effectively is incredible, and being able to deliver that equipment to academics and students to allow them to do that is brilliant.
Theory of machines. Again, another one that we did a webinar on, so we can do a brief tease of this and people can watch the full webinar for further details. Go on, Kyle.
So theory of machines, again, from my personal background, I've worked in gearbox manufacturing, particularly, things like, surface finishing and how that affects vibration in a gearbox. You wouldn't believe the complexities and the simple subtleties that make a big difference into the behavior of a machine when you put all those components together. And vibration is effectively one very key point in that. So our TM1016 is a brilliant piece of equipment, and I'd urge you to go further and have a look at that in regards to its capabilities at understanding damping effects, 2 degrees of freedom, that kind of thing. And again, demonstrating quite complex theory in regards to undergraduate understanding, and enabling them to get a grip really to principles in that format.
Brilliant. And that brings us to the end of the ranges overview. And now I'd like to remind everybody who's watching live, this is a great opportunity to think of all those last minute questions. You can put them to Kyle. We've got Dave sat in the background as well. And of course myself. So do utilize the live chat box, put in your questions. In the meantime, while you pluck up the courage, rack your brain for the questions that you might want to ask, I'm going to talk about TecQuipment as a holistic partner in teaching. Now, one thing that we're very much committed to is not just selling products and actually helping with the practical teaching. It's about being part of the teaching process, helping engage students, and one of those is through the TecQuipment student competitions. This is where we work with universities and colleges to run student competitions where they have to create a video that is kind of testing a theory using one of TecQuipment's pieces of apparatus. And it starts off where you do this competition very much at a local level within your university, perhaps within your course, or maybe it's an extracurricular activity, and then you compete among yourselves. And to compete, you submit this 5-minute video. This is where we're getting all those student videos from that you see once a week. Those particular ones are from Nottingham Trent University, who participated in the 2020 student competition. Now, once you've done your local level competition, then the winner from your university or college can then go through to the international level competition, where all the other winners come together. And then it's like the Champions League, the best of the best are judged, and we have one ultimate winner. Now, if you want to find out who is going to be the winner of the Nottingham Trent student competition, we are doing a premiere on YouTube next Tuesday at 2 p.m. BST. That's about this time next Tuesday. And that's where you can do a preview of all the 16 groups that participated in all their experiments, really see a real range of teaching apparatus and students actually using them. You might want to invite your students to watch this as well. And then at the end, you can see who the actual winner is. They were evaluated based on the quality of the video, but also how well they approach the actual learning process. So have a look at that if you want to get more involved. If you want to be involved in the future, then contact me through either social media or email me at dion.knowles@techquipment.com, and we can begin discussions. We can work with those universities and colleges that have much experience in the past and can help you implement that. We also see ourselves as an important part of helping inform the industry as to different trends. We did a survey more recently that looked at practical teaching and engineering education and perceptions around that, perceptions around the importance of, say, practical teaching for employability of students. And that's an interesting finding that we found out of this study, where we worked with over 100 different academics around the world. 90% of academics believe that practical learning is extremely important for student employability. And there's some more interesting facts that you can find on our website, or if you Google it, you should be able to find this infographic and the full report available as well. Now it's time if you have any questions. Now, I do know we've been answering lots and lots of questions as we go through, so we're not going to have loads now, but we do have one here. Kyle, we have the question, do you have equipment for experimental stress analysis?
Stress analysis in regards, so the piece of equipment that I would recommend in regards to stress analysis would effectively, you could cover that with the stress and strain equipment, but also the tensile tester, really. That would give you a good understanding of how the stress and material functions and behaves.
Right,
The
brilliant.
7,000 range, really.
Okay, Sambet, so hopefully that answered your question thoroughly. Martin has a question now. What spares and repair backup do you provide? I'm not sure whether this is one that you want to hand over to Dave or whether you've got this one.
Yeah, I mean, I'm happy for Dave to chip in as well. He's probably got points that he may like to add. We've got a variety of different support packages with that. We provide spares kits, but obviously the aftermarket team, Andy Ratcliffe and Dave, you know, you're involved in that as well, Dave.
Yeah, that's right.
All support that. So, you know, we've got a great team around the aftermarket side.
Yeah, all the equipment comes with all the necessary tools, be it screwdrivers, Allen keys, spare fuses, spare anything to maintain the equipment. But anything above and beyond that, like Carla said, is available from our customer care team.
Brilliant. Thank you, Dave and Kyle. Just to remind everybody who's watching this live, please do post your questions in the chat box, because we are wrapping this up in the next minute or two. Those watching on demand, you can put your questions in the comment box and we'll come back to you with those in the very near future. So without further questions, that brings me to remind everybody that next week, our next webinar will be back with Dave again, talking about environmental control and solar on the 11th of June. That will be appearing, and you'll get the notifications if you're already subscribing very, very soon. Don't forget to click the reminder bell so that it comes up and reminds you 30 minutes before we're about to go live. It's so easy at the moment with so many webinars and things that people are providing to forget about these great opportunities. So I'm hoping you can join us then. I want to round up by thanking Kyle. Kyle's stepped in and done a fantastic job, and we've had Dave in the background there stepping in to add additional value. So thank you for that, Dave.
Level.
Okay. I said about a paragraph this week. But,
you get to have a week off, Dave.
Yeah,
brilliant. Prepare for yourself for environmental control and solar next week.
Yeah.
But most critically, I really want to say a massive thank you to Murat Islam, who is our guest today, who really put it in context, although Kyle's done an amazing job of putting it in context with all of his examples. But Murat can really talk about his own current experience, and I hope you found our additional presence very, very valuable. Finally, I want to say thank you to everybody around the world who's been watching today, putting their names in the chat box, letting us know where they are. It's really, really helpful. It makes us feel like we're actually talking to people rather than just in the little bubble, me in my corner of my living room, for example. So it's great to see you all there, and I'm hoping you can join us again next week. Don't forget to go back and check at the on-demand webinars if you've missed topics on aerodynamics. Did we do fluid, Dave? I think we did do fluid.
Yeah,
Theory of machines.
Aerodynamics.
Yeah, aero, fluid, theory of machines, and thermodynamics last week. Sorry, Kyle?
As well, Dion, just to mention as well, I think it's been brought up just in the chat as well, and something perhaps none of us really touched on is everything comes with a 5-year warranty. So from a sales perspective, really that's a fantastic benefit. So it's another addition and add-on that TecQuipment provides. So yeah, just get that in there before you wrap it up.
Were you using Andy as your cue there? Yeah. They are done. Well done, Andy.
Yeah.
Right.
Thanks, Andy.
That's it from us today. Thank you very much, everybody, and we will see you next time on the TecQuipment YouTube channel.